To solve a system of nonlinear inequalities, we'll take an approach that's very similar to what we did with systems of linear inequalities. We graph both equations and then look at shading the region of the graph that makes both inequality statements true. First thing we want to do is identify, in this case, we already have our two inequality statements graphed, so that we can focus on examining the different regions where our solution might exist. So as examples, our solution could be the region outside the circle and below equation 2, below that green dashed line. Our solution could be in this, it's not really a wedge, but this little slice of the circle separated by that line. It could be the larger half of the circle, or the larger portion of the circle, located above that line. Or it could be the entire region outside the circle and also above that line represented by equation 2. We have 4 different regions to consider, and what we can do is explore test points until we find a point that makes both inequalities simultaneously true. In this case, we could start off with 0, 0. Plugging that xy coordinate pair into our first inequality will give us 0 is less than or equal to 64, which is true. We need it to make both inequality statements true simultaneously, though. So we'll also plug that pair into the second inequality, which will give us 0 is less than 4, which is also true. That means in this case, 0, 0, and all other points inside our circle, but above that line represented by equation 2, will be solutions to this system of inequalities. In example 2, we don't have the graphs already provided, so we'll start off by constructing those. Inequality 1 is, again, the equation of a circle, but in this case represented with an inequality symbol, and a circle with a radius equal to the square root of 64, or 8. We obviously want to try to sketch these as well as we can, but I'm not a super great artist, so as close as we can come. Inequality 2, if we solve for y, can be represented as a line with an intercept at 8 and a slope of -1, which will have it hitting the x-axis at x equals +8. So we can graph that solid line and then investigate where we should shade. We have 4 different regions to consider: the area outside the circle and above the line and inside the circle and below that line, or below the line and outside that circle. In this case, I already know that 0, -9 is going to be a solution that works for both, but we can test that. By plugging 0 and -9 into the first inequality to get 81 is greater than or equal to 64. And plugging both of those values into our second inequality to get -9 is less than or equal to 8, which is also true. So our solution will be this entire region outside the circle, and below that line represented by equation 2. Be sure to note, again, where we use a solid graph or a dashed graph. In this case, both of our statements had that or equal to component, so we used solid lines. In example 1, the second inequality had a strict inequality statement, strictly less than, so we use a dashed line to represent that boundary, meaning that the points along this line itself aren't solutions, just everything up to it.